In this video, we'll look at graphing quadratic functions from standard form, and we'll find their vertex to do this. First, let's recognize what standard form is. Standard form is when it's written in the form of ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. Once we have these identified, we'll be able to graph this very easily. But first, let's take a look at the base graph to better understand what's going on. If we substitute in 0 for x squared, we get 0. If we substitute in 1, we get 1. 2 will give us 4, and 3 squared will give us 9. And it's symmetrical on the other side, so we could just put 1 and 4 there. And if we start to graph it, 0, 0, 1, 1, 2, 4, and then 3 is 1, 2, 3, 4, 5, 6, 7. That comes off the graph. And that's all right. And we'll go ahead and graph these right here because we have symmetry. And we can go ahead and take a look at the shape. A lot of people say it's U-shaped or it's parabolic. A parabola is the name of this shape. It looks as though it's pronounced parabola, but it is parabola. And things I would want you to notice is, first of all, the symmetry on each side once you have the vertex, as well as patterns that we're going to start to find. So it's really the A-value pattern that I'm looking at. So if we look at what the vertex was, which is 0, 0, we can see how things change. It goes up 1, it goes up 3, and it goes up 5. That is the 1, 3, 5, 7 pattern we're going to use. And then the question is, well, what happens if we multiply by 2? If the A value is a 2, well, this pattern is just going to double. So you're going to have a 2, 6, 10 pattern. We really don't need anything more than that. And then here we have an A value of -1, so we just multiply by a negative. So it's going to go down 1, down 3, and down 5 as we move over. And you'll see all of this in the examples. And if a is 1/2, really the same idea. We would just multiply by a half, so we'd have 1/2, we'd have 3 halves, and we'd have 5 halves. And if you can't follow the pattern, that's okay. You're just going to identify the vertex, and from the vertex, you'll be able to substitute in points on one side and then know that they're symmetrical and have them on the other. And then people will always ask, well, what about B and C? What do they do? Well, C is pretty easy. C is always going to be your y-intercept. Think about it this way. If you substitute in 0, you'd have A times 0 squared plus B times 0 plus C. So 0 times anything is going to be 0, so both of those terms are going to be gone. They're going to go to 0, so you're always left with C. The B is a little trickier. The B value will move it left or right and up or down, and it kind of works with the A value, so it's a little complicated. You'll see that closer if you really get to understand completing the square in vertex form. But for now, we're just going to use this formula that finds the line of symmetry. The line of symmetry, that symmetrical line, is always going to be x equals negative b over 2a. And you can also think of it as x equals negative b, and just take the opposite of the b term, and divide that times 2 times a. So again, you'll always want to get in the standard form, ax squared plus bx plus c, and identify your values. So underneath it, right away, you should always put a equals, b equals, and c equals, whatever they may be. That's going to be helpful. Now, in terms of the y value of the line of symmetry, we're just going to substitute in. So if we substitute back in, we'll get the y value. Substitute back in. So best way to do this is let's look at an example. So here we have y equals x squared minus 2x minus 3. So right away, if there's no number in front, we identify it as a 1, a equals 1, b equals -2, be aware of the minus sign, and c is equal to -3. So again, we're going to start with the line of symmetry, which I'll abbreviate L/S, okay? So that's going to be x equals -2 over 2 times 1. So we have 2 over 2, or x equals 1. And if you want to see what this is on the graph, we can go ahead and put a dotted line right there, a little dashed line there. So that is our line of symmetry, or our fold line. That's what we'll see as symmetry. But now we want the y value. So to get the y value, we're going to substitute that 1 in. So it's going to be whatever that value is squared minus 2 times that value minus 3. And in our case, we know it's going to be a 1 gets substituted in. So we'd have 1 squared is 1, minus 2 minus 3. So we will get -1 minus 3 or -4. So our vertex, we can go ahead and plot, will be 1, -4. So 1, 2, 3, 4 down. There's that point. And we already see our C value is our y-intercept, so we can plot that, go down 3. And then we'll have a symmetrical point on the other side. Now notice the A value is 1, so we're going to have the 1, 3, 5, 7 pattern. I'll just put 1, 3, 5. So when I go over 1, I go up 1. Go over another 1, I go up 1, 2, 3. And we have the same point on the other side. It's reflective image point. And if I go over 1, I go up 5. 1, 2, 3, 4, 5. And we have another reflective image point. So again, that pattern, if I write it on here, is over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, I don't want to keep that on the graph, so let's take those off, but that's something for you to see each time. And then we can do our best to try to connect this. And it's going to be shaped like a U. And some things that are very important here is I want you to recognize our vertex is a minimum. So the vertex is a minimum, so there is no maximum on this. So you'll have some problems that are going to ask you to find the minimum or maximum value. So we can see it's a minimum of y equals -4. All right, and it happens at x equals 1. Okay, let's take a look at our next example. So here we see that a is equal to -1. So a equals -1, b is equal to -6, and c is equal to -2. So again, we're going to do the same thing. Let's go ahead to do our line of symmetry. We'll be in the habit x equals -b over 2a. I'll just write it down up there first. So x equals -6 over 2 times -1. So we have 6 over -2, which will be -3. Now again, we need our y value. So y is going to equal negative that value squared minus 6 times that value minus 2. Now you'll notice I have y equals, this could have just as easily been f of x equal. It's the same thing, so don't let that bother you if you see it. So let's go ahead and plug in -3. So we have -3 squared, which is +9, but we have a negative in front, so we get -9. Negative times a negative, we'll have +18, and then we'll have -2. This will give us 9 minus 2, which is a y value of 7. So our vertex is -3, 7. But you'll notice the a value is negative, so that means we're going to be concave down, so it's going to be a maximum. So we can do something like that. But let's go back to our graph. Let's go ahead and put that line of symmetry, 1, 2, 3, just so we can see it. So it would be here at -3. And now we can go ahead and plug our point in, -3, 7, 1, 2, 3, 4, 5, 6, 7. We just made it. Now, since a is -1, we're going to have the pattern instead of 1, 3, 5, -1, -3, -5. So over 1, down 1, over 1, down 3, 1, 2, 3, and over 1, down 5. So 3, 4, 5. And you will notice the y-intercept of -2 matches up. And again, we can put our reflective image points. And then we can try to sketch as best we can. And there we have our U-shaped or our parabola. And again, if you did get stuck and you weren't sure about that pattern, just go ahead and make a table of values like this. So we have x, y. I put the vertex down first. So I will put the value we found, that -3, 7. And then we just put the points after that, -2 and -1. And then we'll have the same values for the y values on the 2 points on the other side. And then we would just have to do some calculations and go ahead and plug in -2. And we can see from the graph that it's going to be a +6, and then it's going to be a +3, and you'll have the same values on the other side. So if you're given a table of values, it's very easy to find your vertex as well, because it's the turning point. So we were going 3, 6, 7, it turned and went back down to the 6. All right, our last example here. We have y equals 2x squared minus 8x plus 1. So here we can see our a value. A is 2, b is -8, and c is 1. And again, it's a good habit to always do this, less likely to make a mistake. Line of symmetry, again, we'll just write the formula down, -b over 2a. And now we'll go ahead and solve for that. So -8 over 2 times 2. So we'll have 8 over 4, or an x value of 2. So let's find our y value. So y is going to equal 2 times that value squared minus 8 times that value plus 1. And then let's go ahead and substitute in the 2. So we'll have 2 squared is 4, times 2 is 8. Again, follow order of operations. 8 times 2 is 16, plus 1. So we get negative 8 plus 1, or negative 7. So here our vertex is 2, negative 7. And again, the a value is a positive, so that means it's going to be concave up. So it is going to be a minimum value. So let's go ahead and just plot those points. Now go over to, we'll do this without drawing the line in now. 2, then 1, 2, 3, 4, 5, 6, 7. Now, our a value is 2. So instead of 1, 3, 5, we're going to be 2, 6, 10. Let's see how this works out. So we go over 1 up 2. I'm going to put the reflective point right away. Over 1 up 6. 1, 2, 3, 4, 5, 6. And the reflective point does match our y-intercept of 1. And that's going to be good enough for us. So let's go ahead and try to draw that U shape as best we can. I just like to make sure it's not too sharp. We don't want to make it look like a V. It is rounded there. Okay. And that's all there is to it. So I hope that helps. It's real easy to follow those steps.